Okay, now VCAA has released a NHT paper for this year, so I think I need to give it a crack. Now, just notice one thing. These NH papers were still following the previous study design, but I think for math method, it covers most of the content needed for the new syllabus. So let's have a look. All right, first question, always easy. Find the derivative of y equals to x times sine x with respect to x. Product rule here, so dy dx, it will be 1 times sine x plus x times cosine x. All right, tidy this up. Sine of x plus x times cosine x. That's the answer. Next, evaluate 0 to half pi x plus cosine x dx. So we find the antiderivative first, which is half x squared. Remember, you are anti-differentiating. Anti-differentiating cosine gives you sine x from 0 to half pi. Now it's half times pi squared over 4 plus sine half pi. For the upper bound, subtracting the lower bound, 0 plus sine 0. So this chunk will be 0. So basically I'm getting pi squared over 8 plus 1. Okay? Fairly easy. Let's have a look at next. Let f dash of x equals to 3 minus x to the power 3. So we want to find f of x, given that f4 equals to 5 over 4. Well, the one thing I would notice is f dash of x can also be written as minus x takes 3 to the power 3, because this is an odd power. If I take out the minus, then I need to change the two terms here, the order. So making this term positive will make it easier to integrate, okay? So I'm anti-differentiating or integrating minus x minus 3 to the power 3 dx. Well, this is a linear function to the power 3, so I'll raise it by 1 in terms of the power, raise the power to 4. Then divide the odd power. Remember, you also have the inner derivative 1, okay? But we can just ignore that. Don't forget plus c. All right, so we're chucking the value f4 equals to minus 1 over 4 times 4 minus 3 to the power 4, add c, equals to 5 over 4. So now I've got minus 1 quarter times 1 to the power 4, which is 1, plus c equals to 5 over 4. So c equals to 5 over 4 plus a quarter, which is 6 over 4, which is 3 over 2. Don't forget to restate the rules. So f of x equals to minus 1 quarter, x take away 3 to the power 4, add 3 over 2, okay? You can always check, for example, by differentiating to see if your derivative function is the same as this one or this one, okay? Small discussion, I suppose if you keep the original order, you can have, for example, 3 minus x to the power 3 still, but you anti-differentiate this one to get 1 over 4 times minus 1, 3 minus x to the power 4, add a c, which is still minus a quarter, 3 minus x to the power 4 plus c, okay? And that should yield the same answer, because 3 minus 4 to the power 3 minus x to the power 4 is the same as x minus 3 to the power 4, okay? Some of you might use, let's say, this approach. Let's say f of x equals to integration from 4 to x. Remember, when you are using a definite integral, first you need to change the letter to a dummy variable, t and a dt. Next, you need to add the boundary value, okay? Like this. So you basically get minus a quarter, 3 minus t to the power 4. evaluated from 4 to x, add 5 over 4, which then gives you minus a quarter, 3 minus x to the power 4. Subtracting minus, well, be aware of the sign changes here, bracket, okay? And 3 minus 4, that's minus 1 to the power 4. Then add 5 over 4, which still gives you minus a quarter, 3 minus x to the power 4. Add a quarter, add 5 over 4. It's the same answer here, okay? Right. So the next one. The school's first aid room contains 5 first aid kits. 3 first aid kits are red and 2 are orange. Okay, so 3 red and 2 orange. For 3 days in a row, 1 first aid kit is selected at random for an excursion and returned at the end of the day. Very important. If they mention the phrase return, that is the sampling with replacement. So we use binomial because the population proportion or sample proportion doesn't change. Each of the 5 first aid kits has an equal chance of being selected each day. Let R represent the number of red selected over the 3 days. So if we look at a proportion for 1 day selection, that will be 3 out of 5, okay? So that is the probability of selecting a red first aid kit. Now, I could say R is a binomial distribution. N equals to 3 for over the 3 days. 1 day, P equals to 3 over 5. So if I'd like probability R equals to 3, that is basically 3 choose 3 times 3 over 5 to the power 3. And the other probability of failure, which is selecting the orange color, to the power 0. So this is 1, this is 1. So we basically get 3 out of 5 to the power 3. So 27 out of 125, okay? All right, find the standard deviation of the random variable R. So this is a binomial. Binomial mean equals to n times p. Variance is n times p times 1 minus p. So we need to find the variance of R first, which is 3 times 3 over 5 times 2 over 5. I think this will give you, for example, 18 over 25. 9 times 2, 18. 5 times 5, 25. So the standard deviation of R is going to be square root of 18 divided by 25. So that will be 3 root 2 divided by 5, because 18 equals to 3 times 3 times 2, okay? And that's the answer. All right, the next thing. Find probability R equals to 3 given R is greater than or equal to 2. Standard conditional probability problem. So R equals to 3 is intersecting R is greater than or equal to 2 divided by probability of R greater than or equal to 2. So that means I'm taking the intersection to get only one event, which is R equals to 3, the probability. The next line will be probability of R equals to 2 plus probability R equals to 3, okay? Probably should make this vinculum tidier or longer. Let's see. Okay, so now, in the previous part, I've got a probability of R equals to 3. That is 27 out of 125. So probability of R equals to 2 is actually 3 choose 2. 3 divided by 5 squared. 2 divided by 5 to the power 1. So 3 choose 2 is 3 times 9 divided by 25 times 2 divided by 5. So that will be 27 times 2 divided by 125, which is 54 out of 125, okay? Therefore, for the numerator, I will just put in 27 out of 125. divided by 27 divided by 125 plus 54 divided by 125. Oh, fantastic. I can cancel out the 125. So the top will be 27. The bottom simplified to be 27 plus 2 lots of 27, actually. So the top line will be 1. The bottom line will be 3, okay? So 1/3. All right, next. Let g of x be 2 to the power of 2x minus 9 times 2 to the power of x plus 20. So algebraically, I will recognize this as 2 to the power of x whole thing squared minus 9 times 2 to the power of x plus 20. And I want to evaluate this expression where x equals to log 2 of 3. So if I have x equals to log 2 of 3, 2 to the power of x will be the argument, which is 3. Therefore, g of log 2 of 3. Recognize the pattern here, so I can get the value of 2 to the power of x, which is 3. 3 squared minus 9 times 3 plus 20 is 9 minus 27 plus 20. So I believe you get minus 18 plus 20. So this is actually 2, okay? Very simple. Next, solve g of x equals to 0 for x. We already converted the function in a similar quadratic form. 2 to the power of x squared minus 9 lots of 2 to the power of x plus 20 equals to 0. So let's try to factorize that. 2 to the power of x, 2 to the power of x, multiply together. And if you want to get a 20, I would try 5 and 4. But notice we got a minus here, so minus 5 and minus 4. Cross multiply, minus 4 times 1, minus 5 times 1, yep, minus 9. So I'll get 2 to the power of x minus 5, bracket, 2 to the power of x minus 4, bracket, equals to 0. And then I use Nauer factor law. 2 to the power of x equals to 5, 2 to the power of x equals to 4. So x equals to log 2 of 5. Well, I can't keep evaluating this because this is an irrational number, but I don't like answering the second solution like log 2 4. This is not good. You have to write it as x equals to 2, okay? So there are 2 solutions. All right, that's question 4. Question 5. Consider a continuous random variable x with probability density function f given by a linear function. Nice. C and D are real numbers and C is greater than or equal to 1. So firstly, we'd like to find D in terms of C. So what we can do here is, let's think about a graph. Okay, so I could get a minus D here and a D here. This is, let's say, yes, nice. This is actually a straight line. So if I'm chucking in x equals to D, that would be D plus C over 2 as the right-hand side, right-hand coordinates, the y coordinate. And if I chuck in minus D, that would be C minus D divided by 2. So actually, this is forming a shape of trapezium, okay? And if you were drawing the graph, don't forget the 0 parts. Because this is a probability density function, I suppose. Yep, basically you can treat this one as a trapezium and the area has to be 1. Okay, so the area of the trapezium is, well, this is the height. This is the lower and the upper sides, okay? So 2d is the height. I'll add up these two times the height and divided by 2, equal to 1. Half times 2d times c minus d over 2 plus c plus d over 2 equals to 1. So d times, oh yes, c minus d, c plus d, that's just 2 lots of c divided by 2 equals to 1. So c times d equals to 1. Therefore, d equals to 1 over c, okay? Ooh, 3 marks. Okay, right. This is one possible method. Let me just use another method to verify if it's true. If I do the integration, minus d to d, half x plus c dx equals to 1. So I will get a quarter x plus c squared evaluated between minus d to d equals to 1. And then I could multiply both sides by 4, for example. Then x plus c squared evaluated between minus d to d equals to 4. So d plus c squared minus c minus d squared equals to 4. So c squared plus 2cd plus d squared minus c squared minus 2cd plus d squared equals to 4. Excellent. C squared, c squared, d squared, d squared. They subtracted and cancelled. So I have 4cd equals to 4. Well, d is 1 out of c. Yep. Okay. Next, given that ex, the expected value, is 1 out of 24, find the values of c and d. So remember, your c must be greater than or equal to 1, and you have the previous part to work with. Okay, now, I believe, let's try this way. Firstly, the expected value is given by minus 1 over c to 1 over c, simply because d equals to 1 over c. X times half x plus c, bracket, dx equals to 1 out of 24. So then, I think I'll just get from minus 1 over c to 1 over c again. But try to multiply everything with 24 and see how we go. If I multiply 24 both sides, I'll get actually 12 x squared plus cx dx equals to 1. Okay? And then minus 1 over c to 1 over c, 12x squared plus 12cx dx equals to 1. So that is 4x to the power 3 plus, I probably can write this one as 6cx squared from minus 1 over c to 1 over c equals to 1. So 4 divided by c to the power 3 plus 6c times 1 over c squared. Subtract minus 4 divided by c to the power 3 plus 6c still multiplied by 1 over c squared equals to 1. Okay, so basically we have 6c times 1 over c squared. subtracting 6c minus 6c times 1 over c squared. So these two terms can cancel each other. Now I should just get 4 over c cubed plus 4 over c cubed equals to 1. So 8 over c cubed equals to 1. And the c cubed equals to 8. C equals to 2. And you want to find d as well. So d equals to the reciprocal, which is half. Okay? Right. Seems a bit tedious, but still a decent question. Okay, continuous over page. Nice. A graph question. Consider a function f where f is defined on D, mapped to all real numbers. F of x is 3 plus 2 over x minus 1. Okay, a trankers. No, hyperbola, rectangular hyperbola. D is the maximal domain of f. So the maximal domain of f, you just need to make sure the denominator is non-zero. So x minus 1 is not equal to 0. X cannot take 1. Therefore, the maximum domain is D, all real numbers, backslash 1. Okay? And the next thing is to sketch the graph. So immediately you have these two asymptotes. X equals to 1, y equals to 3. So I strongly recommend you use a ruler. Here is a ruler. Okay, now use a ruler to draw a horizontal asymptote, dotted line, and label the equation. Also, you should use your ruler to draw a vertical line, okay? X equals to 1. All right, now, so basically the graph is expected to be first and third quadrant, but we do need to be very careful in terms of the accuracies because the grid paper has been given. So f of x equals to 3 plus 2 over x minus 1. Now, f of 0 is going to be 3. 2 over minus 1, that's minus 2. So that will be 1, okay? Okay, let's see how we go. 0, 1. And if I'm taking f of x equals to 0, 3 plus 2 over x minus 1 equals to 0. 2 over x minus 1 equals to negative 3. So x minus 1 is negative 2 over 3, dividing both sides by negative 3, and multiply by x minus 1. So x is actually 1, take away 2 over 3, which is 1 out of 3. So I think about this point. 1 out of 3, 0. And it's not harmful to substitute a few values in, like f of negative 2. So 3 plus 2 over negative 2. Well, actually, should I substitute negative 1? Negative 1. Negative 1 minus 1. Excellent. 3 plus 2 over minus 2. Well, this is minus 1, so 3 minus 1, 2. If it's at minus 1, I'll be expecting some point like here, okay? And if I'm substituting, let's say, minus 3, then I would say 3 plus 2 over minus 4, which is 3 minus half. Okay, 2.5. Okay, sufficient amount of points, so should be sufficient for accuracy. Make sure I use nice curves to trace out the graph, okay? And using some sort of symmetry, you see, if I pick the 0, 1 here, the distance from this point to the intersection between two asymptotes, yep, I actually expect another point here. Here, here, and here, I suppose. Finally, I need to make sure everything has been addressed. The axial intercepts, the asymptotes, good shape, well, reasonable. It's not perfect, but it's reasonable. Okay, so let G equals to 1 over x and the domain is r backslash 0. Determine the rule of the function h such that the graph of y equals to h gx minus 1 is identical to the graph of y equals to f of x. Interesting. So basically, we'd like to think about gx minus 1. That will be 1 over x minus 1, isn't it? Now, we'd like h gx minus 1 equals to f of x, which is 3 plus 2 over x minus 1. So it will be very handy if you recognize 3 plus 2 times bracket 1 over x minus 1. So simply speaking, you can write this as h g of x minus 1 equals to 3 plus 2 lots of gx minus 1. Well, the idea is this is equal to gx minus 1. You can just change it. And what if I put this as a? So h of a will be 3 plus 2a, okay? So we want the rule of the function h. Now, it's better off in terms of x. So h of x equals to 3 plus 2x, okay? Ooh, it's not difficult, it's just a little bit different, but a decent question. Oh, by the way, well, in the current study design, we could also see something like y equals to h, a little hollow circle, g bracket x minus 1, okay? This is another identical or equivalent notation, like the fog, golf stuff, okay? Just remember the second function is substituted into the first function, like in the normal bracket way, okay? Okay, righty-ho. Question 7, 6 marks. F of x is log e 3 plus 2x minus x squared. Find the implied domain of f. So, we just need the quadratic function to be positive, okay? Because log e something positive only. Okay, so we'd like this inequality to be true. Now we can take, let's say, 3, 1, minus x, well, it doesn't work. Minus x, plus 3x minus x, 2x. Yep, so I should get 3 minus x, 1 plus x greater than 0. Then think about a quadratic graph. I should get something like this is a minus 1, 1, 2, 3. So we can trace out a quadratic curve, a parabola. Okay, here comes a parabola with the turning point at 1, I suppose. Okay, if it's greater than 0, then this is a negative parabola. We can only take this part, excluding the two x-intercepts. So we'd like to see x belongs to minus 1, 2, 3, okay? Or in this form, minus 1 less than x less than 3. It has to be, open circles, okay? You can't take 0 because log e 0 is undefined. That is the implied domain. And the stated coordinate for the local maximum of f of x. It tells you it's a local maximum of that function. So I think f of x equals to log e of 3 plus 2x take away x squared. So if I differentiate this function, I will get 3 plus 2x minus x squared as my denominator. And the numerator will be the derivative of the inner function, okay? So it's 2 minus 2x equals to 0. Denominator cannot equal to 0. So 2 minus 2x equals to 0. X equals to 1. Whoa. This is very handy. It only looks for the x coordinate. I start to wonder how the graph would look like. Actually, I suspect that's how the graph should look like. In fact, I suppose the two x values, this is x equals to minus 1. This is x equals to 3. Here is a local maximum, 1, natural log 3 plus 2 minus 1, 4. And if I substitute 0, that will be natural log of 3, slightly lower, symmetrical, and it's some sort of, some sort of graph like that, okay? With bounded between the two vertical asymptotes, but no horizontal asymptote. Okay, find the values of x when f of x equals to 0. So, log e of 3 plus 2x minus x squared equals to 0. But can I turn this into a log form? Well, log e1 is 0, okay? So we can actually equate the bracket 3 plus 2x minus x squared equals to 1. So I can change everything to one side. Let's say x squared minus 2x. And 1 minus 3, that's negative 2, okay? Equals to 0. So let's try to make it x squared minus 2x equals to 2. But then I could also complete the square by adding a 1 to each side. So we can actually get x minus 1 squared equals to 3. So x minus 1 is basically plus or minus root 3. Don't forget a plus or minus. And x equals to 1 plus or minus root 3. Okay, so that explains everything. So this point is actually 1 minus root 3, 0. This point is 1 plus root 3, 0. Yep, that explains everything. So here you have a 0, natural log 2. Lucky. Those students didn't need to draw a graph of this function. But drawing this graph of this function is not hard at all if you can combine part A to C, the three parts, the result. Okay? All right, let's have a look at the last part. Consider the function f, where f is restricted on all real numbers and f of x is a sum of a quadratic and a sine function. And the function g, where the domain of g is R, but the equation of g is not known. Part of the graph of y equals to f of x and y equals to g of x are shown below. Both functions pass through the origin. Excellent, pass through the origin. Now, based on the graphs above, state one reason why the graph of y equals to g of x is not the graph of y equals to f dash of x. So let's have a closer look. G of x is not the derivative of x. It's basically, this is what the question is asking. And now if I take a closer look. Okay, so let me change to a thinner pen. So let's say if I choose one stationary point here along the graph g of x, it actually aligns to the x-intercept of f of x. So if I choose another stationary point here, okay, right, it also matched another x-intercept. And the stationary point here, yep, it also matched the x-intercept of 0, 0. Here is another stationary point, yep, aligned. Another stationary point, aligned, okay? So basically, right, so how should I, actually this is not a stationary point on G. I'm a bit, okay, so if I treat my G of x as original function, then this f of x should be the derivative. Because whenever the function of f is above the x-axis, the corresponding part along the graph G will be increasing. Otherwise, it will be decreasing, okay? So because the 4 stationary points on y equals to g of x have the x values aligned to the 4 x-intercept on y equals to f of x. That implies f of x equals to g dash of x. Okay, given that g dash of x equals to f of x, yep. So it should be the other way around. Alternatively, we could also, it's just one reason. So we could also say when f of x is greater than 0, the parts on y equals to g of x is increasing. When the graph f of x is below the x-axis, the parts along g is decreasing, something like that. I mean, you could also have other sorts of reasons, but let's just look at the other parts. Determine the equation of g of x given that g dash equals to f of x. So I need to anti-derive f of x. Let me just take a snippet here. Okay. Now, g of x is anti-deriving 1/3 x squared plus sine pi x dx. Oh, 3 marks. Okay. So basically I should get 1 out of 9 x to the power 3. We are raising the power divided by the new power. Sine, anti-deriving sine will give you negative cosine pi x. But don't forget to divide the constant here. Minus 1 over pi cosine pi x plus c. Okay. Since both functions pass through origins, so I should be expecting 0, 0 on y equals to g of x. Okay. g0 equals to 0. Origin. Then I should get 0 equals to 1, 9 times 0 minus 1 over pi cosine 0 plus c. So 0 equals to minus 1 over pi times 1 add c. So c equals to 1 over pi. Okay? And the question wants the equation of g of x. So g of x equals to 1 over 9 x cubed minus 1 over pi cosine pi x plus 1 over pi. Fairly straightforward, generous remarks. Some functions have the property f of x equals to f minus x for all x belongs to real numbers. Show that when two functions m and n have this property, their function k of x equals to mx plus nx also has this property. If m of x and n of x are, this is an even function, then mx equals to m minus x, n of x equals to n of minus x. So mx plus n of x equals to m minus x plus m minus x. And the left-hand side is m plus m, which is k of x. K of x. The right-hand side is actually k of minus x. Therefore, k of x also has this property. This is basically saying if one function is even, another function is also even. When you add up two even functions, you will get the resultant function even, okay? Finally, consider the function h, where h of x is 1/3 x squared. Well, this is a quadratic, plus sine pi x minus c. Find all values of c for which h of x equals to h minus x. Well, this is exactly using part c. So, based on part c, if h of x equals to h minus x, then 1/3 x squared is even and sine pi x take away c is also even, okay? Let n of x equal to sine pi x take away c. All right, let's see how we go. So we'd like to do some sort of a translation, I suspect. Let's have a look. Let's consider y equals to sine pi x. And it's some sort of translation thing, I suppose. So let's write this one as sine pi x minus c divided by pi, okay? The graph of sine pi x, let's try to use a gray color. Period equals to 2 pi over pi, which is 2. So I could say this is one part here. This is another part here. This is also another part here. Well, that's not enough. That's just a half cycle, but I think it serves its purpose. I can also duplicate this bit. Like that, I suppose. Actually, like this. All right. So if I want this function to be even function, well, let me label these points. 1, 2. Basically, the half is the maximum turning point, so I can just get Get close enough. All right, so I can translate this function by half unit to the left, okay? Or let's say half unit to the right. Yep, if I translate by half unit to the right, that will be an even function, okay? Or half unit to the left. So I could say, all right, could translate y equals to sine pi x by half units left or right. So basically I could argue that c over pi equals to, let's say, half or minus half. But it's asked for all values of c. So, well, this is minus half. The horizontal distance is like a multiple of 1. Okay. In terms of general solutions, I could say pi c over pi equals to half plus k, all right, or minus half plus k, and k is any integers, okay, from here to here to here to here. Okay, it's actually the horizontal distance, half period, okay? So c is actually half pi plus k, or minus half plus k pi, multiply pi here, okay? And I think if you just write down one solution, that also includes this possibility. So these two expressions are identical to each other. Overall, c equals to, well, you could also put it as plus or minus half pi plus k pi. And it encompasses all the possible answers, okay? I mean, it's just a horizontal shift to the right by half plus k unit, or minus half plus k unit, okay? All right, so that should cover all the solutions. Now, this is an interesting question, okay? You may want to use another algebraic way to verify your finding, but I think a graphical approach will be more transparent. Okay, now I think that's the end of the solution. Well, I'll probably find some other time to do the exam 2 for this method. Heard this method paper was very straightforward, similar to the last November paper. See you later.